Hello everyone. This video is to tell you a little bit about counting lists. So the first thing I want to tell you is what I mean by a list. A list, or alternatively a word or a sequence, is just an ordered set. So there are lots of different kinds of lists in the world that we might want to count. We might want to count the number of phone numbers, the number of DNA sequences, student ID numbers, login names, social security numbers. And the questions we want to ask are really like, how many are there? Largely because we're worried, are we going to run out, right? Do we have enough possible student ID numbers for the size of our student body? Questions like that. Okay, so how do you systematically count ordered lists of things? Let's think about this example where we have phone numbers. So we might ask the question, how many different 413 phone numbers are there? So phone numbers that have the prefix, the area code 413. Well, there are going to be 7 more digits in the phone number. So 1, 2, 3, and then 4, 5, 6, 7. So we have 7 choices to make. And when we think about it, okay, so how many choices do I have, options do I have for each choice? Well, there are the digits 0 through 9, and there are 10 of them. So 10 digits, 0 through 9. And I can use any of them, right? So that gives me 10 choices for the first spot. And then for each of those 10 choices, I have 10 different choices for the next spot and 10 different choices for the next spot, etc., etc., etc. So I really have, I see 10 choices for each of the spots, and there are 7 spots. So there should be 10 to the 7th phone numbers that start with the area code 413. Okay, so let's make this a little more interesting. We can ask, let's vary this question a little bit. How many 413 phone numbers contain exactly 19? All right, so still we have 1, 2, 3, 4, 5, 6, 7 spots to fill. And we know that one of them contains a 9. So what we need to do is choose where the 9 goes. So there's only one 9. So there are 7 spots that I could put it in. So this is 7 choices. Now there are 6 spots left, and I have to choose a digit to put in each of the 6 remaining spots. But I can't use a 9 because there's only one 9 and I already placed it. So that means we have only 0 through 8 remaining. To use. So we have 9 numbers here, 9 numbers, and that's why the total number of 413 phone numbers containing exactly 19 should be 7 for the number of places where we can put the 9 times 9 to the 6th, because I have 6 more spots where I have 9 digits that I can put in each of those 6 spots. Okay. So what if I want to think about this other variant? How many contain at least one 9? So here we're again thinking of how many 413 phone numbers are there. In other words, how many, I have 7 spots left to pick. And now Okay, let's think about this. Like, there are potentially a lot of different cases, right? I can have exactly 1 9, and then I have to figure out where to put that 9 and then how to put in the rest of the digits. Or I could have 2 9s, and I could think about where to put those, etc. Or 3 9s, or 4 9s, to 7 9s. And so, as soon, like, one of the sort of mathematical principles is that cases are sometimes necessary, but kind of ugly. And so whenever you find yourself splitting a problem up into a lot of cases, like, where a lot is maybe more than 2 or 3, you should try to think if there's another way to think about it, a better point of view. And in this case, there is. So instead of cases, we can think about the set of all phone numbers like this. There's this set of all phone numbers, set of all 7-digit phone numbers. And this set is the phone numbers with at least 1 9 union the set of phone numbers without any 9s. So there are 2 cases. A phone number either has a 9, in which case it's in the first set, or it doesn't have a 9, in which case it's in the second set. So this original set is the union of these 2 sets, and there's no overlap between them. Okay, so if I want to find the size of the set of phone numbers with at least 1 9, I can say that numbers with at least 1 9 is equal to, so the size of the set of numbers with at least 1 9 is equal to the set of all phone numbers minus, maybe I'll write that over here, minus the size of the set of all phone numbers without any 9s. So the first thing we did was compute the size of the set of all phone numbers, and we found that was 10 to the 7th. And now if we think about, well, how many phone numbers are there that don't contain any 9s? Well, we have 7 slots to fill, and now we can't put a 9 in them, so we only have 0 through 8 that we can choose. So there are 9 numbers, 0 through 8. So here we have 9 to the 7th. So, and this was really nice. Now there are no cases at all. Okay, let's see. So those were lists. I wrote lists with replacement. So where's the replacement here? I mean that I can use any digit as many times as I want. After I use it in one slot, I kind of can put it back and replace it and use it again and again and again. Okay, but sometimes we want to count lists where we have a finite set of options for the elements of the list, and we can't reuse any of them. So that's a list without replacement. And that might happen like if you're playing a game of Scrabble. So suppose you have 7 Scrabble tiles, all different letters. And let's suppose they're M, R, C, L, E, U, H. How many different 7-letter words or lists can we make these tiles? So these words are just lists. They don't have to make sense. Okay. Well, let's think about it. Here we have 1, 2, 3, 4, 5, 6, 7 slots to fill. And let's think about how many choices we have to fill in each slot. So for the first slot, we can put any of the 7 letters in. So we have 7 choices. Okay. But after we put 1 letter in, then we can't use it again. So for the next slot, we'll only have 6 letters left to choose from. And that continues, right? So for the next slot, we only have 5 letters, and then we have 4 letters, and then we have 3 letters left, 2 and 1. So in this case, If we want to think about the number of lists that we can make without replacement, it would be this number 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and then finally, suppose you're not you're like me and I'm not very good at Scrabble. So if I have seven Scrabble tiles, I almost never get a 7-letter word. I end up with these like terrible 3-letter words. So you might ask, well, how many 3-letter words can we make with these tiles? So now we'll have 3 spots. 1, 2, 3. We have 7 tiles to use, and again, we can't reuse them. So this is a list without replacement. So we're going to have 7 choices. We can use any of the 7 tiles for the first letter of our word. We'll have 6 tiles left for the second letter, and we can choose from among 5 tiles for the third letter of our word. So the number of 3-letter words is 7 times 6 times 5. Okay, that is it for today.